Hey, so we're going to do this integration today. So it looks simple, but actually I don't think it's very simple. Okay, so I'm going to show you how I do it. If you have a better method, do let me know. Okay, so first of all, I'm going to divide the numerator and denominator by u square. Okay, so I'm going to get 2 over 1 over u square plus u to the power 4 divided by u square is just u square. Okay, so this is the first step. And I'm going to separate this. Okay, so how am I going to separate this? I'm going to introduce some new expressions. Okay, so this is 1 plus 1 over u square. The bottom stays the same. Okay, plus 1 minus 1 over u square. And the bottom stays the same. Okay, so notice that if I add this up, the 1 over u square and the negative 1 over u square will cancel out, right? And I'll get 1 plus 1, which is 2. Okay, so it's meant to be the same. Okay, so what do I do from here? Okay, I'm going to manipulate the denominator. So how do I manipulate the denominator, right? 1 over u square plus u square is... yeah, okay, so it's u minus 1 over u square plus 2. Okay, so 1, yeah, just check. So if I expand this out, I'll get u square plus 1 over u square and yeah, minus 2 plus 2. Okay, yes, that is correct. And then I will do the same for the other one. Okay, so this would be u plus 1 over u square minus 2. Okay. All right, so there's a reason why I did it this way, because I noticed that, if I were to differentiate the denominator, I would actually get something very close to the numerator. Okay, so that gives me a hint. Okay, so I'm going to use some substitution to help me out here. I suspect that I can use a trigo sub, so I'm going to try using a trigo sub. Okay, so I'm going to let u minus 1 over u be square root 2 tangent theta. Okay, so the reason for using this substitution is because when I square this, right, I get 2 tangent square theta, right? So 2 tangent square theta plus 2 is actually, okay, just let me write it here. 2 tangent square theta plus 2 is 2 times tangent square theta plus 1, right? And that's identity, right? So tangent square theta plus 1 is secant square, right? So this is actually 2 secant square theta. Okay, so this is what I'm trying to achieve. Okay, but I need to replace the du as well. So I'm going to differentiate this, right? I'm going to differentiate the left-hand side with respect to u. So differentiating this, I should get 1, and differentiating negative 1 over u, I should get plus 1 over u square, right? du, and differentiating the right-hand side, it should get square root 2 secant square theta d theta. Okay. Now, I know that the denominator, in fact, I already simplified here. Okay, so let's plug in the expressions, right? Okay, so anyway, I'm dealing with this part first. Okay, I'm going to do it separately. You can call it part 1 and then part 2. Okay, so I'm going to do part 1 first. Okay, maybe I should just write it here. This is part 1 and this is part 2, right? So I hope I don't confuse you. Okay, so I'm dealing with part 1 here. Okay, so this is part 1. Okay. Okay, so, well, if I put in a substitution, I should get, or rather this should transform to square root 2 sine square theta over 2 secant, oh yes, did I say sine? Okay, secant square theta divided by 2 secant square theta, d theta. So if you simplify that, yeah, it's going to be quite simple. Root 2 over 2 d theta, right? Which is just root 2 over 2 theta. Okay, so I'm going to just leave it in terms of theta. Okay, Okay, maybe I'll just substitute the theta, right? Because ultimately you want our answer to be in terms of u. Okay, so let me deal with that first. Okay, so I'm gonna erase some stuff, more space. Okay, so how do I replace the theta with u? Okay, so tangent theta is actually u minus 1 over u divided by root 2, right? So tangent theta is u minus 1 over u divided by root 2. I'm going to draw a little triangle to help me out. Okay, so triangle, tangent theta. Tangent is opposite over adjacent. So this is the opposite, and root 2 is adjacent, right? Okay, so I can use Pythagoras theorem to find this side, right? So this is u minus 1 over u squared plus square of square root 2 is 2, right? Square root. Okay, so I think this will come in handy, right? So now, what is theta? Theta is, okay, actually I just realized that I don't have to do that. Okay, so root 2 over 2 theta, right? Because I already know that tangent theta is this. So theta is just tangent inverse of u minus 1 over u divided by root 2. Okay, I don't know why I went through the trouble. Okay, so this is simply just root 2 over 2 tangent inverse u minus 1 over u divided by root 2. But I think I might have to use this trick for part 2. Okay, so let me erase this away. This is kind of useless already. Okay, so now let's do part 2. Okay. So part 2, I kind of expect to use the same substitution. Okay. So for part 2, I think I would use okay, I'm going to use this identity, right? I mean, it's the same identity. So secant square theta minus 1 is equals to tangent square theta, right? So this is the hint I have. Okay, so part 2 will be okay, well, let u plus 1 over u be equals to root 2 secant theta. Okay, so yeah, let's differentiate first, okay? So differentiate both sides, okay? Differentiate the left side with respect to u. I should get 1 minus 1 over u square du equals to, differentiate secant theta is secant theta tangent theta. So this is root 2 secant theta tangent theta d theta, all right? Okay, so substituting, we should get square root 2 secant theta tangent theta divided by 2 tangent square theta d theta. Okay, so let's simplify that a little bit. Maybe I can write the constant multiple outside. Tangent theta divided by tangent theta, so I get secant theta over tangent theta. Okay, so can I simplify this? I think I would do that first. If I simplify secant theta over tangent theta, I should end up with cosecant theta. Okay, so this is cosecant theta. Okay, and integrating cosecant theta. Okay, so what do you get when you integrate cosecant theta? You get ln of cosecant theta minus cotangent theta. Okay, so now I'm going to use the triangle to help me. Okay. So I know that for part 2, secant theta is u plus 1 over u divided by root 2. Okay, so I'm going to draw a triangle to help me. Okay, so this is theta, right? Let's say this is theta. Secant is 1 over cosine, right? So cosine would be root 2 over u plus 1 over u. So adjacent, yeah, cosine is, okay. So cosine would be root 2 over u plus 1 over u, right? So adjacent over hypo. Okay, so using Pythagoras theorem, this is u plus 1 over u squared minus 2 square root. Okay, so this is Pythagoras theorem here. Okay, so that would help me to find cosecant, right? Because cosecant is 1 over sine. Okay, so sine theta, right? What is sine theta? Sine theta is opposite over hypo. Okay, maybe I will skip this. So what is cosecant? Right, so cosecant, okay, let me get the pen. Okay, so cosecant theta would be u plus 1 over u divided by square root of u plus 1 over u squared minus 2, right? So that would be cosecant theta. Okay, and what is cotangent theta, right? Cotangent theta, which is, well, tangent theta is opposite over adjacent, so cotangent theta, which is a reciprocal, will be adjacent over the opposite. So it'll be square root 2 over square root of u plus 1 over u squared minus 2. Okay, so rewriting this, right, this is root 2 over 2 ln, instead of cosecant theta, I can write it as 1, u plus 1 over u divided by square root u plus 1 over u squared minus 2. Okay, and then minus cotangent is root 2 over square root u plus 1 over u squared minus 2. Okay, so this is our answer for part 2, right? So the final answer would be, of course, the combination of part 1 and part 2. Okay, so this is our part 1. Okay, and this is part 2. Okay, so yeah, there we have it. All right, so it's the sum of these two, and don't forget to plus that arbitrary constant c at the back. Okay, so that sums up the integral. Okay, so do let me know if you have a better method. I'll see you in the next video. Bye.